Ever feel like you're staring down a coding problem and it's just massive? Like you wouldn't even know where to start?
Yeah.
Well, you're not alone.
It can be really intimidating, right?
It really can.
Yeah,
But that's why we're here today.
absolutely.
For this deep dive, we're talking all about practical strategies to kind of up your problem-solving game when it comes to code.
For sure.
We're taking a look at a super popular online guide I'm sure a lot of you have heard of.
Yeah.
It's called How to Approach a New Coding Problem.
Yeah, it's a classic.
It is a classic.
And for good reason.
Mhm.
It just lays out a really solid framework,
Right.
which is something as coders we all need,
It's true.
no matter your skill level.
Absolutely. And this article, it outlines 10 steps, but we're going to focus on just the most impactful ones today.
Yeah, just the meat.
Exactly. And more importantly, how to use them.
Right. Yeah, get
Right.
practical.
Yes, exactly. Because I think sometimes we can get lost in the weeds with all these different things to keep in mind. But sometimes it's like, what are the most important things I need to take away?
Yeah. What can I apply right now
Exactly.
to my project?
And step one seems deceptively simple. Understand the problem.
Oh, so important.
I know.
It sounds obvious.
Right.
But this is where I think a lot of people, even seasoned programmers, trip up.
Mm-hmm.
We just jump into the code before we fully grasp what's being asked of us.
That's so true.
You know, like trying to bake a cake without realizing that you're missing half the ingredients.
Yes. And this guide, it gives a great example, finding the maximum element in an array.
Okay.
So it sounds simple enough,
Yeah.
but did you consider an empty array?
Oh,
Did you consider strings instead of numbers?
right. All those edge cases?
Exactly. And that's where those clarifying questions come in.
Absolutely.
And that's also where I think if you are working on a real project, it's okay to go to your team
Oh, yeah. Talk to people.
and ask those clarifying questions.
100%. If it's a real project, talk to whoever wrote the specs.
That's exactly.
If it's a practice problem, think about all those possibilities. Like
Yeah.
you said, those edge cases.
Yes.
That's how you avoid those gotcha moments later on.
Yes. And, you think you understand the problem, but you don't really fully grasp it until you've asked those questions.
Right. It's like those assumptions we make.
Exactly.
We fill in the gaps
Yes.
with our own assumptions, and sometimes they're not right.
Exactly.
And then you're going down the wrong path.
Exactly.
You've wasted all this time.
Okay, so you've dissected the problem.
Okay.
Now what?
Right.
So the guide emphasizes analyzing examples, and I think this is where things click for a lot of people.
Yeah, 100%. Think of it like reverse engineering a gadget.
Okay.
You know, you're not just seeing the final product, but you're figuring out how each part works together to achieve that outcome.
Oh, that's a good point.
Yeah.
And so the guide uses a really simple example, reversing the string hello.
Okay. Yeah.
And so when you think about it, you're like, okay, how do I get from hello to Allah?
Yeah.
But when you really break it down step by step and you
Yeah.
see like, okay, the H goes here and the E goes here, and like you really visualize it,
You got to visualize it.
I think it makes all the difference.
It's like that aha moment when the light bulb goes off.
Yes.
And this is where you start to see patterns emerge
Okay.
that you can apply to other problems.
That's a good point.
So maybe you notice that reversing a string
Mhm.
has similarities to like swatching elements in an array.
Oh, interesting.
Right.
Okay.
Recognizing those patterns is key to becoming a more intuitive programmer.
So it's like leveling up your coding instincts.
Exactly.
I like that.
Yeah.
But what about those monster-sized problems that just make you want to like hide under your desk?
Oh, yeah, for sure.
Because sometimes you get those requirements and you're just like, I don't even know where to start with this.
It's overwhelming.
It is overwhelming.
Yeah,
And so the guide suggests breaking it down.
absolutely. Step 4 is all about divide and conquer.
Okay. I like it.
Yeah. Imagine climbing a mountain. It's way less daunting if you focus on just reaching that next base camp
Okay. Yeah.
instead of like fixating on the summit the whole time.
That's a good point.
You know,
Yeah.
so break it down into smaller steps.
And it makes the problem a lot less scary.
Exactly.
And the article uses a really good example, I think, of sorting algorithms.
Okay.
Because those can be pretty intimidating.
Yeah, they can be.
Especially when you first learn about them, but when you break them down into smaller tasks,
Yeah.
like picking a pivot element or recursively sorting subarrays, it becomes much more manageable.
Absolutely. And this is also where your knowledge of data structures and algorithms becomes really crucial.
Okay.
Because, for example, the guy talks about finding the nth largest element in an array.
Okay.
Now, you could sort the whole array
Yeah.
and then just pick the nth element.
Right.
But a more efficient approach might involve using a heap.
Okay, I was going to ask, why is a heap more efficient in that scenario?
That's a great question. It's all about how heaps are structured. Think of it like a binary tree, where each parent node is greater than its children.
Okay.
This structure lets us find the north largest element without sorting the entire array, saving us time and resources, especially with huge data sets.
So it's kind of about choosing the right tool for the job.
100%.
And I think that takes us to step 5,
Okay.
which is plan, don't just code.
Oh, so important.
I know, and it's so tempting to just jump right in.
Yes, especially when you're excited about an idea
Yes,
and you just want to get going,
you just want to get it out.
but you've got to plan it out.
That's so true, because you can waste a lot of time
Absolutely.
getting down the wrong path.
Yeah, like an architect wouldn't start building without a blueprint, right?
Right, right.
We need to map out our strategy.
Mm-hmm.
What data structures are we going to use?
Yes, what are the trade-offs of using certain data structures versus others?
Exactly, and that's where experience really comes in handy.
Yeah. It's true. The more you code, I feel like the better you become at choosing that most efficient path.
Absolutely. It's about recognizing those patterns we talked about
Yeah.
and having that mental toolbox ready.
So it sounds like planning is about working smarter, not harder.
100%.
We've talked about understanding the problem, analyzing examples, breaking it down, and planning our approach. What comes next on this coding adventure? We'll find out after a quick break.
So we're back, and we've been talking about how to tackle those coding challenges. But, even the most elegant plan can kind of go astray when we actually hit the keyboard.
Yeah, totally. It's like having a great plan, but then not executing it properly.
Exactly.
You can still trip up.
Yeah.
And this is where I think step 7 testing is so crucial.
Oh, absolutely.
Because it's tempting to just skip ahead, you know?
I've been guilty of that.
Yeah, we've all been there, right?
Yes.
But, testing, and I'm not just talking about making sure that your code compiles without errors.
Right.
It's about ensuring that it actually solves the problem correctly in all scenarios. That's a good point.
Right.
Yeah, it's like testing a new car, right? You wouldn't just drive it around the block and be like, yeah, I'm good.
Exactly.
Like, you got to take it on the highway, you got to test the brakes, make sure it can handle those tight turns.
Yeah, those edge cases,
Exactly.
Like, does it work when it's raining? Does it work when it's snowing?
Yes, exactly.
All the different conditions.
You got to test it out.
So start with those example cases
Yeah.
that are provided in the problem.
Exactly. Does your code produce the expected output?
Right, and I think this is where people get tripped up sometimes. They're like, oh, it worked for that one case, so I'm good.
Right. You feel good about it, but then you get to like an interview scenario and they're like, okay, well, what about this edge case? And you're like,
oh no.
Yeah.
I didn't even think about that.
Right. Those edge cases can expose vulnerabilities in our logic that we might not have even anticipated.
Exactly, and I think the guide uses a good example here.
Talking about a function to find the maximum value in an array.
Yeah.
So we need to make sure it handles an empty array, an array with just one element.
Right.
An array with all negative numbers.
What if they're all the same number?
Exactly.
Yeah.
What if all the elements are the same?
Yeah.
So it's really thinking about all those different possibilities.
Absolutely, and this is where I think tools like print statements and debuggers become so valuable.
Yes.
They're like your coding X-ray vision,
I like that.
allowing you to see, peer inside your code's execution and see what's happening at each step.
So it's like being a code detective.
Exactly.
Following the clues.
Following those breadcrumbs
Yes.
to figure out, why is this not working the way I expect it to?
I love it. Okay, so let's say you've written your code.
Oh,
You've
yeah.
tested it thoroughly.
Yep.
Everything's working beautifully.
Feeling good.
We're good. Right.
Oh,
Right.
no.
We can just move on.
It's so tempting.
It is tempting.
But the guide urges us to take one more crucial step. Reflection.
Okay, so this is where we get to celebrate our coding triumphs.
Well, it's more than that. Step 9, reflecting on your solution, is about turning a single problem into a learning opportunity for future challenges.
Mm.
Ask yourself what worked well in my approach. Were there any roadblocks, and how did I overcome them? Did I learn any new techniques that I can add to my coding arsenal?
It is kind of like that. It's like leaving that trail of breadcrumbs so that other people can follow our logic. Or even for ourselves, when we come back to it like 3 months later and we're like, wait, who wrote this?
Oh, yeah, 100%. We've all been there.
Why is this so messy?
Yeah.
Why didn't I comment this?
Yeah, good documentation is like having a conversation with your past and future selves.
I love that.
Like you're explaining it clearly and concisely so that they understand.
And the guide gives a great example with this.
Okay.
Using the findMax function that we talked about earlier. So it's like, okay, here's a description of what the function does. Here are the parameters. Here are the return values. Here's the time and space complexity.
Exactly. It's about making your code more understandable and accessible for everyone, including yourself down the line.
It's true, and we've covered a lot of ground today.
We really have.
From understanding the problem to documenting our solution.
The whole shebang.
But this is just the beginning.
Absolutely.
Learning to code, it's a journey, it's not a destination.
That's true.
And the real magic happens when we actually put these techniques into practice.
100%. When we apply them to real problems.
Exactly. So, are you up for a challenge?
I'm always up for a challenge, especially when it comes to coding. What do you have in mind?
Okay, so here's the mission. I challenge you to take one problem from the guide's examples. It could be the findMax function, the string reversal, anything that really piqued your interest,
Okay.
and try to solve it using these steps.
I love it. It's not about memorizing solutions. It's about internalizing these strategies.
Exactly. And don't just code it the way that you normally would, like really take the time to understand the problem. Analyze examples, break it down, plan your approach tests, thoroughly optimize if you can, and of course reflect.
And don't forget to document your thought process along the way.
Yes.
You might be surprised by what you learn about your own coding style.
That's such a good point because it's really about embodying that spirit of a true problem solver.
Absolutely. Always be learning.
Yes, always learning, always refining your craft, and I think that's how you become a better coder.
100%.
So ask yourself, what worked well, what was challenging, what would I do differently next time?
Reflection is key.
It is so important.
Yeah.
Well, thank you so much for joining me today. It's been so fun diving deep into this guide with you.
This is great. I always love talking about coding and problem solving.
Me too. And to all of you amazing listeners out there, keep coding, keep learning, and keep diving deep.
And remember, have fun with it.
Yes, coding is supposed to be fun, and we'll see you in the next episode.